Hey everybody, Mr. Mall here. So we're going to go over negative feedback and homeostasis. So these are pretty fancy terms, but it's what we saw in our thermoregulation lab. Is we saw while the external temperature was changing, so like our skin temperature was changing, our internal body temperature should have roughly maintained the same. It might have fluctuated a little bit. But we're going to go over negative feedback. So it's how our body maintains normal. That's huge because without normal, our body goes through some rough times. Like if you have a fever, you don't do well. So let's see what we're going to cover. So one, we're going to cover how our body recognizes an issue. So how we recognize what's going on. Two, how it responds. Three, why it responds. Okay. And by the end of this, you should be able to explain why our body goes through these certain changes when it's hot or cold and what the real importance is. So, feedback loop. What is a feedback loop? Well, a loop is a circle, so it means it repeats. So, these feedback loops never stop. Your body's doing this right now. Unless your room is perfectly aligned to your body temperature, your body is either trying to warm up or cool down right now. Okay? So that's what a loop is. A feedback is what I get on my papers and assignments. So it's information. So feedback is corrective information. So it's information that's trying to correct an issue, and we're going to see that in a minute. We're going to talk about negative feedback. Now, negative feedback does not mean bad. Okay. Negative feedback, a lot of people get this misconception that, oh, it has the word negative in it, so it's either bad or always decreasing. That's not true. So the big thing, and this is the big kind of, if you remember one thing, remember this right now. Negative feedback is to maintain balance or maintain normal. So your body temperature is 98.6 degrees Fahrenheit. Your body tries to maintain that at all costs. Okay, so that's the big thing. It will sacrifice things. So, as I talked about in my previous videos, if it's really cold out and you're getting frostbite, your body will pull blood away from your skin to try to keep the core of its body warm. It will sacrifice these things. So, that got me thinking, what's this sound like? Well, that sounds like our buddy Thanos. Okay, so he wanted to keep everything in balance. Now, if you haven't watched the movies, basically, he's a bad guy from the Marvel Universe. He wanted to kill off half the universe's population because he saw so many things going on. He believed that if we kill off half the population, a lot of these bad things in the universe will stop happening. So let's take a look. So, why did Thanos do all this? One, he saw that there were too many people in the universe. That's just an observation he had. Two, Thanos sees all the misery of overpopulation, starvation, disease, wars, things like that. So he actually sees this stuff now. Okay. Three, Thanos sets a goal. He believes that removing half the population will solve it. Four, he snaps his fingers and poof, half the population is gone. So that's the change he makes. And then five, everything's good. Well, we hope. So that's kind of the timeline Thanos went through. Now, weirdly enough, that's kind of what our body goes through every once in a while. So let's take a look. Now, this table has both hot and cold. Okay, but right now, let's not worry about the cold. All right, we'll look at that one in a second. But what we are going to look at is on the left here, we have the actual terminology and vocab that you should know by the end of us talking about feedback loops. Will you have it memorized by the end of this video? Probably not, but it's stuff that we want to start talking about. So a stimulus. A stimulus is any change outside the body. So if I throw a ball at you, that's a stimulus. You're going to catch it. Okay? So a stimulus is anything that kind of makes a change happen. So the stimulus we're going to look at is it's 105 degrees out and our body is overheating. That's the stimulus. It's causing a change. So that's step one. Step two, the receptors in our body get information. So we have sensors in our bodies, all over our bodies. So the sensors in our body start to see that our blood is actually warming up because of the temperature outside. Three, our control center, or our brain, gets all this information from the sensors. Okay, it's like a spy. The spy sends an information back to headquarters. So controls of the brain. So this is HQ. This is headquarters. Okay, oh, bad Q. And then 4, a change happens, or what we call an effector. Okay, so the effectors we see when it's really hot out is our body sweats, and actually our body pushes blood to the surface of our skin so that we can try to get rid of some of the heat in our blood. This is why your face turns red or your skin turns red when you're working out or it's really hot out. Your body's actually trying to get rid of some heat. And 5th, there's a response. Hopefully, our body temperature lowers back to this 98.6 degrees Fahrenheit. So that's our body using negative feedback to try to maintain temperature. So when it's too hot out, our goal is to lower temperature. Okay, that's our goal. But now if we look all the way to the right, I'm going to use my blue pen for this one because we're going to be talking about cold. So our stimulus is we see that it's negative 10 degrees out and our body is freezing. That's our stimulus. Okay. 2, our receptors, our sensors, are seeing that our blood is actually cooling down. They're cooling underneath that 98.6 degrees. 3rd, our brain gets that information from the sensors. It sends it up the spinal cord, all the nerves, it gets all that information. 4, the effectors, our body starts to shiver, starts to contract muscles to try to generate heat, and it actually pulls blood away from the skin. So the further blood is away from the skin, the warmer it will stay. That's its hope. So that's why our body turns blue when we're really cold, because we have a lack of lack of blood and oxygen going to the skin. Now you do that too long, that's frostbite. And then 5, hopefully the response, our body temperature raises back to this 98.6 degrees. Now you might be thinking, I've heard this before. This is all called homeostasis. Homeostasis is the idea to maintain normal in your body. We're talking temperature right now, but this happens with everything. Temperature, carbohydrates, glucose, sugar, well, same thing, insulin. So all these things are trying to be maintained in the body. Water availability, osmosis, that all happens. We're trying to maintain a balance. So let's keep looking. Here's my balance beam. Okay, so we want to be nice and happy right here. We don't want to be too cold, we don't want to be too hot. Now if we get too hot, well, we got to bring that balance beam back down to make sure it's nice and balanced. So let's go back up to my awesome example of Thanos. Okay, so let's go through this. So first, Thanos, there are too many people in the universe. This is his stimulus. This is what is going to end up causing the change. There's too many people. Thanos sees all the misery. So this is the receptors. Okay. Receptors and sensors are starting to see that there's an issue. Well, the receptors send that information to the control center, or in this case, that'd be Thanos. Okay, so Thanos gets all that information, and the control center makes a choice. Like, it's got to do something, and his do something is to remove half the population, and that's what he does. So this change, this effector, is removing half the population. So it's a bad O. So the effector is removing half the population, and then number 5 is the response, is that hopefully decrease famine, decrease wars, things like that. So those are the steps of negative feedback. Negative feedback is trying to maintain normal. It doesn't matter if it's an increase of something or a decrease in something. If our body's too hot, we have to decrease temperature. If our body's too cold, we have to increase temperature. It's all about finding that middle ground. Some people call it the Goldilocks theory, where it's like not too hot, not too cold, not too high glucose, not too low of glucose, not too high of insulin, not too low of insulin, everything like that. So not too high of water, not too cold and low of water. So those are all things where our body tries to maintain this nice little middle ground. So that's negative feedback in a nutshell. Hope you guys got everything. If not, pause, rewind, go back through it.